Okay, this is how to find the moment of inertia of a solid sphere. Solid sphere, the integral. By definition, it's I r squared dm. Remember, it's all those little pieces of mass and with their distance from the axis of rotation squared. So we're going to solve this for a solid cylinder.
What's the inertia?
Yeah, moment of inertia. Solid or hollow. Okay. All right, the dm is an issue because we can't know those little dm's. So that we are going to redefine as rho dv. And why do we do that? Because rho is mass over volume. So if I have a dv and then I could just take my v's out and I get my little dm's, right? Okay. When we do this, we're going to take that cylinder and we're going to divide it into little hollow soup cans. So my dv is going to be defined as 2 pi r. That's the circumference, and then L, the length, right? And then our little thicknesses, which that right there is going to be my dr. So it's going to be 2 pi r L dr. This is my dv. Okay. So rho dv is going to be equal to 2 pi r L dr, and then rho. So now my integral is going to look like this. I equals, I'm going to pull out all the constants. 2 pi L rho, okay? The integral of r cubed. Why r cubed? Because I got an r there and I got an r there. So now they're going to be multiplied together. dr. All right. I is going to be equal to 2 pi L rho r to the fourth from r1 to r2. All right. All right. So the I is going to be 2 pi L rho r2 to the fourth minus r1 to the fourth.
What happened to 1/4?
The 1/4.
Oh, right, okay. 1/4. Thank you. Thank you. All right. Yeah. All right. This expression here, I can do completing the square. So I could say that is going to be equal to 1/2 pi L rho r2 squared minus r1 squared times r2 squared plus r1 squared. Now to get rid of this rho, this is an expression for density. Rho equals mass over volume. Now we're talking about not the volume of a soup can, but the actual volume of a cylinder. It's different. The volume of a cylinder is going to be equal to, volume of a cylinder is pi r squared L. But if it's hollow, you have to subtract that little inside bit. So this is a solid, but if it's hollow, which we want to allow for in our integral, it's going to be pi
It's R to the
R2 squared minus R1 squared pi L times that. Okay, that's volume. There. Okay. So now I'm going to take this expression, this is the volume and this is rho, right? Okay. And I'm going to pop it in there. So I've got a pi over 2 times L times mass divided by pi times L times R2 squared minus R1 squared times R2 squared minus R1 squared times R2 squared plus R1 squared. So I took this expression here and substituted this for my density. So now I is going to be equal to 1/2 m R2 squared plus R1 squared. And that is the moment of inertia of a solid or hollow cylinder, being that if it's solid, this guy is 0. Yeah, thank you.